Let's take a look at the following. If we wanted to locate the vertical asymptotes over here for a function, if f of x is p of x divided by q of x is a rational function, and please make a note of this key thing where p of x and q of x don't have any common factors. And if a is a 0 of q of x, it means that when you put a for x, then q of a is going to be 0. So all they are saying is that a is a value of x that makes q of x what? That makes q of x 0. Okay. So they're telling you that if you have such a value, then you will have a vertical asymptote at this value a of x. When x is equal to a, you will have a vertical asymptote of the graph of f. So all they are saying here, it looks maybe a little bit complicated. First, when you look at f of x is p of x over q of x, make sure that p of x and q of x have no common factors, because if they do, you will not get a vertical asymptote from the value that makes its common factor 0, but rather you will get a hole in the graph, something more like this, a little gap in your graph. To get a vertical asymptote, remember, it's a line to which the graph gets closer and closer and closer and closer. To get such a vertical asymptote, you need to have p of x and q of x having no common factors. And to find the equation of this vertical asymptote or those vertical asymptotes, you need to take q of x, the denominator, and set it equal to 0 and solve for x. Once you find those value of x, at each one of those value of x, you will get a vertical asymptote. So that's all they are saying. Now, to find the vertical asymptotes of a graph, if they exist, but sometimes you don't find any, then you need to proceed in this following way. For example, for this function right here, which is f of x is equal to x over x squared minus 1. First, you need to compare the numerator and the denominator and make sure they don't have any common factors. If you were to factor the denominator, x squared minus 1 is a difference of two squares, which can be factored as x plus 1 times x minus 1. And when you compare the numerator and the denominator, they have no common factors. So we can proceed to find the vertical asymptotes. What we need to do is take the denominator, what they call q of x, so the denominator, and set it equal to 0. They call it q of x if you want to refer to the previous slide. So set the denominator x squared minus 1 equal to 0. So what you can do is add a 1 to both sides and then take the square root of both sides, and you get two values of x equal to plus 1 and negative 1. So those zeros that make the denominator 0 over here, so those values of x that make the denominator equal to 0, so at x equal to negative 1 and x equal to 1, the denominator is 0, so we say that those values negative 1 and 1 are called the zeros of the denominator. They make the denominator 0. So at those values over here that make the denominator 0, we expect to have two vertical asymptotes, and the equation for those is x equal to negative 1 and x equal to 1. Let's take a look at the graph in the next slide. Notice that we indeed have at x equal to negative 1 and x equal to 1, which are drawn in red over here. We do indeed have the graph of the function. If you look at this distance, it's shrinking as we go down this way, and also it's shrinking right here as well, and doing the same here and there. So what happens is that the graph is shooting down here, and this is shooting up here, shooting down here, and shooting up there. So we indeed have vertical asymptotes over here for this particular function. Note that we had two vertical asymptotes in this case. So VA stands for vertical asymptotes. What are their equations? One was x is -1, one was x is 1. So in order to graph those, you need to have something like real values for x. If those are real numbers, you can go ahead and find if this is your y-axis, your x-axis. Then you can find x is 1, x is -1. Those are the values and those are the vertical asymptotes that you are drawing. So there need to be real values that you can locate on the x-axis in order to draw those vertical lines. Now in the next slide, you'll notice there's a problem, okay? In this particular slide, you notice that now let's take a look at this slide over here. In order to draw the vertical asymptotes with equations listed over here, you need to go ahead and have two real values for x. -1 and 1 are values I can find on the x-axis, and I can draw a vertical line passing through those two x values. So when you have real numbers right here, then you can graph those vertical asymptotes. What happens when you don't? Take a look at the next function. If you have a vertical if you are looking for vertical asymptotes for the next function, which I have right here, you will notice that this particular function, if you were to take the denominator and set it equal to 0 and solve for x, then you'll get that x is plus or minus little I. So that's by setting the denominator equal to 0. I cannot find that anywhere. You know, when I'm looking on the x-axis trying to find where I is, I don't have a clue what that is. It's not related to a number line that's dealing with real numbers. So because you cannot draw over here those two equations here, then you do not have any vertical asymptotes for this particular function. And remember that if you had a vertical asymptote, then the graph, if this is the case, the graph is going to over here. Let me do it in another color. When you have a vertical asymptote, the graph is either shooting down, you know, over here, or shooting up, either to the left of this asymptote or to its right, and possibly on both sides it's having some of those behaviors. So look back at the graph over here that we were looking at. When you take a look at this last function that we have, you don't have the graph shooting through, you know, through the top or, you know, through the bottom over here, and you do not have an asymptote at all that is a vertical asymptote in this situation.